Hello viewers, welcome back to our channel. Now today we want to find the area of the green region in this radical geometry problem. So how do we find the area of the green region? Now we'll start by making this quadrant a complete circle. Remember it is a quadrant because the angle at the center OA is given to be 90 degrees. So if you make this diagram a complete circle, then we'll have center of the circle is O. So we have this point is D, point A, B, C, D. So we can let this new point here to be point E. Now if you look at this, the radius of this circle from O to D is 8 meters, meaning from O to E is as well going to be 8 meters. Now you can see from O to B is also the radius, which is 8 meters, but it is divided into two equal parts at point A. So when 8 meters is divided into two equal parts, it is going to be 4 meters by 4 meters. So if you look at this, since DE is the diameter, then basically DA is of equal length with EA, meaning this length is the same as that length because the length OA is at 90 degrees and we have OD and OE are of the same length, meaning point O, the line AO is a perpendicular bisector of a line BE from point A. Now, how do we find the green area? Now to start, we will have to get the length DA or the length AE because they are of equal lengths by just using Pythagoras theorem. So how do you get the length DA or the length AD? So the length AD you will use, because the length AD is the longest side, that is hypotenuse, will be opposite squared plus adjacent squared is hypotenuse squared, meaning AD will be the square root of 8 squared plus 4 squared. So the length AD using Pythagoras theorem is the square root of 8 squared plus 4 squared. And you get it to be, that length is 4 root 5. So the length AD we found is 4 root 5. So this length here is 4 root 5. Then it means the length A to E as well is going to be 4 root 5. Now after getting the length AD, we can now get the length from A to C. How do we get the length AC? So if we let the length AC to be X, we can use the theorem of intersecting chords. Remember, from the point O to the circumference here is also radius, that is 8. So the theorem of intersecting chord, if I let this point here to be F, you can see the chord BF intersect with the chord CE at point A. So if you use the theorem of intersecting chords, it means from A to C, then times A to E is going to be equal to from B to A, from B to A, then times from A to the end of that chord, which is F, from A to F. So that is the theorem of intersecting chord. The chord CE intersect with the chord BF. So we've said C to A is X, then A to E is 4 root 5. So X times 4 root 5, we are going to have 4 root 5 X to be equals to B to A. From B to A is 4, then A to F. So that is going to be 4 times from A to F is 4 plus 8. That is 12. So for you to get X, you divide both sides by 4 root 5. You divide both sides by 4 root 5. So 4 root 5 goes with 4 root 5. We remain with X is 4 goes with 4 is 12 over root 5. So it means the length from C to A is 12 over root 5. So how do we get the green? How do we get the green area? How do we get the green area? Now for you to get the green area, remember we need the length CD. You can get the length CD by using Pythagoras theorem. So how do we get this length from C to D? So the length from C to D is going to be given by CD is one of the shorter side, the longer side is hypotenuse. That is going to be the square root of the hypotenuse is 4 root 5, so 4 root 5 squared, that is 4 root 5 squared minus the other shorter side is 12 over minus 12 over root 5 squared. So what is CD if you use Pythagoras theorem? AD is the longest side hypotenuse. So you get there CD to be, you use the Pythagoras theorem, CD will be the square root of the longest side, which is 4 squared, then minus the other shorter side is 12 over root 5. So if you square that, what do we get? 16 root 5 over 5. So 16 root 5 over 5 will be, so CD is 16 root 5 over 5. So we found this length from C to D is 16 root 5 over 5. Now, having found all the lengths, we can now get the green area. Now, how do we get the green area? So you start with the area of the quadrant. So if you start with the area of the quadrant ODCB, so the area of the quadrant will be pi r squared divided by 4. And remember, radius is 8. So you get that to be pi r squared, that is pi into 8 squared over 4. So pi r squared we will have, so you get the area of the quadrant is 16 pi. So the area of the quadrant is 16 pi. Then the area of the triangle ADC, so if you take triangle ADC, this triangle ADC, what is the area? The area is a half base times height because it is right angle triangle. So the base and height we have 12 over root 5, a half times 12 over root 5 times 16 root 5 over 5. 16 root 5 over 5. Now if you work out that, root 5 goes with root 5. You remain with 2 goes here once, here 6. So 6 times 16 over 5. So that is going to be 6 times 16. 6 times 16 over 5 is going to be 96 over 5. So the area of that triangle is 96 over 5. Then the area of triangle ODA. So the area of triangle ODA is also a right angle triangle. At this point, that is a half base times height. So that is a half times 4 times 8. And you get that area to be 32. 4 times 8 is 32. Divide by 2, that is 16. So how do we now get the green area? Now the green area is simple. It is the area of the whole quadrant, which is 16 pi minus the area of the two triangles. So the area of the whole quadrant we found is 16 pi. Then it is minus the area of the two triangles. The area of the first triangle we found 96 over 5. Then plus the area of the second triangle we found is 16. So what do we get the area of the green region? So the area of the green region is 15.0, is approximately 15.07 if you round off to the nearest two decimal place. So that area is approximately 15.07, and remember our unit is what, in meters, so it is 15.07 meters square. Thank you for watching and see you again in our next presentation.